Welcome to Brain Vision.
In this question, we have to determine the inner radius of a shaft from two different ways. First, from torsion formula, and second, from the shear stress distribution when there is an applied torque of T over 2. So from torsion formula, we will have that tau maximum, it is equal to Tc over J, or C is actually R, right? And J is pi over 2 to the power of 4. So we have that the Tmax is actually 2T pi R to the power of 3. And if we want to find R that at T equal to T over 2, so we'll have that Tmax is T divided by pi R that to the power of 3. Now, and sorry, this is not tau max, this is tau. And we have that tau is actually R that over R tau max. So we have that T over pi R that to the power of 3 is equal to R that over R 2T divided by pi R to the power of 3. So that makes R that equal R over square root 4 of 2, root 4 of 2, and it is 0.841 times R. That is the answer from torsion formula. And from the shear stress distribution, we can write down the relation like this, and from that we'll have that pi is equal to tau is equal to rho R tau max rho square e rho, and rho is 0 to R that, and we can substitute tau max by 2T pi R to the power of 3, and we'll have that T over 2, which is the integral of dt times 4T R to the power of 4 integral of rho to the power of 3d rho, and that makes that equal to R over the fourth root of 2, and that's the same as what we have found from the torsion formula.